All right, so how about a quick little application? So what we're going to do is show that the area of this circle is r squared. And what we're going to do is just take this part right here. Come on, grab the highlighter. Right here. And find the area of that. And if we find the area of that, that's giving us our first quadrant. That way we can make our theta between 0 and pi over 2. Then we can just take that and multiply it by 4 at the very, very end. So first, we're going to make our rectangle. And so this is dx, and we need y equals for our rectangle. So that's going to be the height of our circle. So if we go over and solve our circle, we get y squared equals r squared minus x squared. So y equals the square root of r squared minus x squared. And that's our top circle. So this would be y equals square root of r squared minus x squared. It's giving us our positive version of it right there. Okay, so now if we do our integral, we're going to go from 0 to what? So we know that's 0. Well, our circle has a radius of r. Right here is r. That's r, right? So that would be 0 comma r. This would be r comma 0. So you can see our x value goes from 0 to r. And then our height is the square root of r squared minus x squared dx. And so by taking the integral, it's going to give us the area of this. Well, how many are there? 4. So that is our area of our circle. Just like that. So now what we need to do is solve for this. So we're going to go x equals, and this is a sign because it's minus x squared, and it's r sine theta. And then that way we can replace it. So dx equals r cosine theta d theta. And then now we need to plug it in to find our two values. So 0 is our x, and we get r sine theta. So 0 equals sine theta, because if you divide by r, it's still 0. Theta equals 0. And then now we're going to go x equals r. So r equals r sine theta, and that's 1. So sine theta is theta equals pi over 2. So now we know what to use for our integral. So this will become a equals, here we can actually go over here now and plug it all in and find out what it is. So a equals 4, 0 to pi over 2. And then we're going to plug that into here. So this would become square root of r squared minus r squared sine squared theta. And then r cosine theta d theta. So by taking out that r, again, we're going to end up with r cosine theta, just like that. You can take it slower if you want. So this would be r squared square root of 1 minus sine squared theta. So that would be r cosine theta. Okay, so then we also have an r cosine theta here. So this would now become 4r squared. And since r is not a theta, we can actually take it out. So 4r squared, you can see it start to build itself. 0 to 2 pi. Nope, not yet. Pi to pi over 2. Cosine squared theta d theta. And then again, whenever we see that, we rewrite it as 1/2. 1 plus cosine 2 theta d theta. Let me move it down because I wrote it too high. 0 to pi over 2, 4r squared. And just to make it look a little nicer, we can actually bring that half out. And we can do that all at once. So that would be 2r squared, bracket. And then now the integral of 1 would be theta. And the integral of cosine would be 1/2 sine 2 theta. Move that in a little bit more now. And we're going from pi over 2 to 0. Okay. So we already know when we plug in the 0, that's going to be 0 and that's going to be 0. So we don't have to. We already know it's going to be minus 0 because sine of 0 is 0 and that's 0. So we just have to deal with the pi over 2. So we have 2r squared, and then this would be pi over 2 plus 1/2 sine, and then pi over 2 plugged in with 2 is pi. So that is also 0. So this would become 2r squared pi over 2 plus 0, which the 2's cancel and you end up with pi r squared. So there is the area of our circle. We knew that the equation of a circle is x squared plus y squared equals r squared based on the radius, and we used it with trig substitution to find the area.